So we are going to learn a little bit about Boyle's law, another characteristic of gases. So we've been learning about gases. And Boyle's law is that the pressure in one volume at that specific volume is going to be the same at a pressure with a pressure at another volume and a different pressure. So in other words, if you had a volume of gas that had, so we would say the first volume that has 2 liters for the volume, and we say that the pressure in that first volume, the one is to identify the first part of our experiment. So we have the volume in the first part and the pressure in the first part. And so P1 would, let's say that the pressure in the first part of this experiment is 100 kilopascals. Well, we want to know what happens if we change the pressure to 500. So the second pressure would be 500 kilopascals. What would then be the volume of that under that new pressure? So one of the first things you do is you write down your unknowns. So this is just an example. You have a volume that has a setting of 2 liters. That's the first volume, and a pressure of 100 kilopascals. And you then decide to put that under a pressure of 500 kilopascals, and you have to figure out, well, what's the volume going to be? So this is Boyle's law. And the only thing we need to do is put these in the equation and do a little algebra. So our equation is P1 V1 equals P2 V2. So let's just do a little work. We'll put P1 in, which P1 is 100 kilopascals. We got that from there. And we're going to multiply that by V1, which is 2 liters. Then that is going to equal P2, which we're going to get from up here, of 500 kilopascals. And then this is the variable that we need to solve for. So in order to solve for this, we have to do a little algebra. So first, we're going to multiply these two things together. 100 times 2 is 200 kilopascals liter. Remember, I'm leaving the units on. I'll just put a bracket around it so we would remember the units. And that's going to equal 500 kilopascals times volume 2. So we have to solve for V2. In order to do that, then we have to divide this side by 500 kilopascals. And if we do that on this side, we have to do it the same on this side. So on this other side. So we have to divide by 500 kilopascals. So we have 200 divided by 500, and we actually then would get, on this left-hand side, this would solve to be 0.4 liters equals volume 2. So, in other words, we took this pressure and volume here, this is the first setting, and then as soon as we increased the pressure, then the volume had to decrease. And you can understand that. So if you took a balloon and you decided to take that balloon and increase the pressure in it, by increasing the pressure, you would actually just be making the balloon smaller. You would be squishing it down into a smaller volume. And that's what happened here. We started with 2 liters, and then we ended up with 0.4 liters. So that's an example of how Boyle's law works. I'm going to now do the applications that are on page 46. So page 46, let's read through the first question. Question 1. If a pressure of 70 kilopascals on a volume of 80 centimeters cubed is reduced to 10 kilopascals, by what factor does the pressure change? So this question is again about Boyle's law, and the first thing you want to do is write down what they told you. Let's start with the pressure at the beginning. The pressure at the beginning would be P1, and that's going to be 70 kilopascals. Now I hope you all have your books in front of you to see that. The pressure is at 70 kilopascals, and the volume, the first volume, V1, is 80 centimeters cubed. Now they say they put a final pressure down to 10 kilopascals. So what would you expect the volume to be? They want to know by what factor does the volume change to when you change the pressure. Well, in this case, let's just take a quick look at the equation of Boyle's law, and let's look at what we're doing in this case. We are decreasing the pressure. Let's again think of a balloon. And if you decrease the pressure, and if in other words, you are able to pull all the sides out at the same time, somehow pull it all out, what happens to the volume then? Does the volume increase or decrease? Well, of course, if you decrease the pressure, then the volume would decrease. So let's write this equation out. Let's go ahead and do the math. P1 is 70 kilopascals. V1 is 80 centimeters cubed, and that equals P2, which is 10 kilopascals, times V2. And remember, they want us to determine what V2 is. Now let's look again to figure out where we got these things. We got P2 from here, we got V1 from here, and we got P1 from here. Okay? So we have our equation, and I just want to reiterate, one of the first things you want to do is write out what you know. This is called the given. Write out what you have been given. Once you have a list of what you were given, you're able to easily solve the equation. So let's take a look at this equation here. And in order to solve for V2, we have to divide on this side by 10 kilopascals and divide on this side by 10 kilopascals because you're doing it on both sides. Now last time I kind of skipped a step, but I want to show you that if I divide by 10 kilopascals, the kilopascals gets divided out because kilopascal over kilopascal is 1. And 10 divided by 10 is 1. So the only thing we have left is the V2. Now on this side, we have kilopascals, which is going to cancel out this kilopascals. And then we have 70 times 80 centimeters cubed divided by 10. Well, I just like to do this math in my head real quick. I'm just going to say that divide 70 by 10, and that gives me 7. So 7 times 80 is 56. And then you add a 0 to the end. 560 centimeter cubed equals volume 2. So that is our solution for problem number 1 of the application. Let's look at the second problem. Oh, before we go too far, let's see if that makes sense. We started again with 70 kilopascals and we had a volume of 80 centimeters cubed. Then we decreased the volume. If we decrease the volume, we would expect we decrease the pressure. If we decrease the pressure, we would expect the volume to increase, and that's what happened. The volume got bigger. Let's look at problem 2. Let's read that together. If the pressure on a gas quadruples, how does the volume of the gas change? So this is a tough question because they don't give you any values. So I'm glad I'm going to do this one for you. It takes a little thought. But let's do this. Let's say that we start out with a pressure of P1. And let's say we start out with a volume of V1. Then what they have told us is that the pressure is going to change to 4 times. They're saying the pressure on a gas quadruples. So if the pressure quadruples, that means that the second pressure is going to be 4 times the first pressure. That would be quadruple. Quadruple. That means multiply it by 4. So multiply the second pressure by 4. And then they're asking, what is the volume? What would the volume be? Well, let's just enter it into our equation. P1 V1 equals P2 V2. Well, we know what P2 is. So let's write this again. P1 V1 equals, instead of putting P2, we put 4P1 V2. Then we want to solve for V2, so we divide by 4P1 on both sides. And that would cancel that pressure on that side. We're left with the volume 2 here. On this side, pressure 1 divides out, and so we're left with V1 divided by 4 equals V2. So when they asked if the pressure on a gas quadruples, in other words, if it gets multiplied by 4, what happens to the volume? Well, the volume actually decreases by a factor of 4. Let's take a look at question number 3. If the volume of a gas doubles, what happens to its pressure? Now, hopefully you watched the last problem and you would understand kind of how this works. Let's start this again. We don't have any values. We're going to say P1 equals P1 and V1 equals V1. Then they say, well, what happens to the pressure, the P2 pressure? I don't know, but they do know that the volume is going to change to 2 times the amount it originally started. So 2 times V1, because it doubled. That's what the problem said. It doubled. Now let's do our equation. P1 V1 equals P2 V2. We substitute in P1 V1 equals, instead of P2, or instead of PV2, we're going to put 2V1. Again, to solve for P2, you have to divide by 2V1 on this side and do the same thing on the other side. This would cancel there. V1 canceled here, and so we have P1 over 2 equals P2. So in this case, they took the initial volume, they increased it by twice the amount. In doing that, the pressure actually divided in half. So the same factor, the 2, actually goes to inversely change the pressure. So the second pressure is going to be the original pressure divided by 2. Let's take a look at the fourth problem. If a mass of air has a pressure of 100 kilopascals and a volume of 200 liters, if it is compressed to a new volume of 80 liters, what will be the new pressure? Again, this is a pretty straightforward problem with just the same amount of algebra. But let's do the problem in the same order. Let's write what we've been given. Well, the P1, the initial pressure, is 100 kilopascals, and the initial volume is 200 liters. Then it is compressed to a new volume. The new volume is 80 liters. You see how it's changed from 200 to 80. They want to know what P2 is. Well, let's write our equation. P1 V1 equals P2 V2. So we'll stick what we have in, 100 kilopascals, because that's P1, times the first volume, which is 200 liters, which comes from over here. That equals P2. We don't know what that is. That's what we want to solve for, times 80 liters. So then we do a little bit of algebra. We divide on this side by 80 liters, and we're going to divide by 80 liters here. And so the liters would cancel out. You would actually have 100 times 200 divided by 80, and the units would be kilopascals. And you can just run that in your calculator and you can get the answer. But you see how these problems are fairly easy, just a little bit of algebra to solve for them. And you'll find that the initial pressure and volume is related to the final pressure and volume, and it's related inversely. So that when you increase the pressure, the volume goes down, and when you decrease the pressure, the volume goes up. That's it. Thanks.